All right, we are looking at solving this question out of the homework assignments about increasing annuities. And this is a kind of a bit of a compound problem. We've got two parts to it. One is where we're investing the money every month into the account, making deposits every month into the account. So that's an annuity sort of thing. We're making regular deposits. It's a future value annuity because we're building up money. We have an increasing annuity, a future value annuity there. And it's an ordinary annuity because the deposits are made at the end of the month. We're going to do that for 5 years, and then after the 5 years, we're going to leave the money without making any additional deposits. So at that point, we'll use the compound interest formula to find out what happens to the money that we've initially accumulated with the annuity. So we're going to start with that present value annuity. PV is equal to R, your payment, times 1 plus R over M to the MT. And to make this look right, I need another set of parentheses in here. So R parenthesis 1 plus R over M to the MT power minus 1 all divided by R over M, and that long division bar is a grouping symbol. We want to do the division on the bottom before we do the overall division, so I need another set of parentheses down there. So for the first part with the annuity, we want to find out what happens to that $170 a month. Our R is going to be 170. The interest rate, it tells us, is 8%. We're compounding things monthly. There are 12 months in a year, so our M would be 12. And I'm going to start with an exponent of 12 times 5 to start off with. Finally, minus 1 as part of the formula, and then divide by the R over M. And that will give us how much money we'll have at the end of the 5 years when we're making monthly deposits. Let's switch over the calculator and find out what that number is. So I want to do, let me clear off what's there. I want to do 170, oops, got a 170 times parenthesis 1 plus 0.08 divided by 12. Close that first parenthesis off. Raise that to there's the raise to the power there. It's 12 times 5, which is 60. It's easier to do it in your head, but if you're going to do it on the calculator, you do have to do that in a set of parentheses because the calculator will follow the order of operations. It'll do multiplication or exponents before it does multiplication. We want to do that multiplication before we do the exponent. And then subtract the 1, and then close off the parenthesis to finish off the top of the fraction. And then I want to finish by dividing by that R over M, which would be, again, as mentioned before, needs to be in parentheses, 0.08 divided by 12. Close parentheses, and then it equals. And so we'll have about $12,491 in the account at the end of the 5 years, the first 60 months of payment. So I've got 12,000, let me see how well I can remember what that number was, 491.07. 491.07. Let me double check to make sure I wrote it down correctly. And yeah, that's how it rounds. All right. And then what I want to do is I want to use that as the starting value in a just a standard compound interest problem. So A equals P times 1 plus R over M to the MT. That's the formula we use for compound interest when we're only starting with a single dollar amount. And so I'm going to put that in as the P. And then the interest rate remains 8% annually, or 0.08 over 12 would be your quarterly rate. And we're going to do that for 24 years. So I'm going to do 12 times 24 up there in the exponent. And so then we just need to do the calculations there. I'm going to hop back to my calculator. All right, and you know what? I'm just going to take the previous answer there. I'm going to take my previous answer, and I'm going to multiply it by parenthesis 1 plus 0.08 divided by 12, close parenthesis, raised to the 12 times 24. By using the previous answer, I keep all that precision that my calculator is keeping track of, and it makes my answer more accurate here. Sometimes these computer programs are very picky about that if you round off partway through your equation, you'll end up with an answer that's wrong, or that gets marked wrong because of the rounding error. And so try to avoid rounding if at all possible. And so then my total would be $84,659.89. So that would be our final answer there.